Hello everyone, in this particular video we are going to see what is the need of container orchestration. Okay, because till now what we have seen is with the help of docker run command or with the docker compose we are able to start one or more containers. Okay, so now there are few questions that needs to be answered. Okay, like the first question is, do you need scaling beyond one host? Okay, now let's say you have only requirement of let's say 50 containers, okay, or 100 containers or 30 containers. Okay, so in that case, if you have a big enough host, you can definitely deploy all these 30-50 containers on a single host. Okay, but if you have a very huge application or a huge cluster in you required where you have thousands of containers, okay, in that case it is not feasible to have all the containers on the single host. Okay, so for the first question that we need to ask us is that is there a need of a more than one host? Okay, if that is the case, then this is a one more reason to have the container orchestrator which can manage multiple hosts. Okay, the next question that we should ask is the high availability. Okay, do we need high availability for your application? Okay, if we require that, in that case we need a orchestrator who will provide this high availability. Okay, then the next question that is, are your containers truly stateless? Okay, because what we have seen is once we start the container, whatever we do inside the container, if we just container gets killed or stopped, whatever the data that generated inside that container, that will be lost. Okay, so if you want to maintain states, in that case we need a orchestrator which will help us to manage that state. Okay, now if you see how in the production environment what are the requirements. Okay, we already covered some requirement like we need high availability. Okay, the next requirement that we need is availability. Okay, so what this availability means, it just has to be working all the time with the as little as downtime possible. Means if your application is running, okay, so at any point of time this application should be accessible. Okay, otherwise what will happen, if your application is not accessible, then you will be not able to serve your customer. Okay, so we need your application to be available all the time, okay, with very little downtime. Okay, now next is the performance. Okay, performance of your application is very important. Our server needs to be handle traffic, so performance is important. So that means if suddenly if there are very huge requests coming from the user, in that case also we should be, our application should be able to handle that traffic and should respond that properly. Okay, so the performance is very important. Now the next requirement, the production requirement, is the application should be easily deployable. If you need any update, it should be easily upgradable, or if there is something wrong, then it should be easily rolled back. It should be easily rolled back. Okay, so all this feature we required. Then we need some mechanism for logging mechanism as well as some matrix mechanism. Okay, so all these are the some important requirements are there in the production. Okay, so all these requirements can be made using the container orchestrator platform. Okay, so if you see few more like scheduling. So what is scheduling? Let's say you are starting the container and you have a multi-host environment. Okay, in that case where this container should be run. Okay, because we have a multiple host, but we have to choose the best host where you can start the container. Okay, so that's why we need to have a scheduling support in this container management. Then the next is management. Okay, who manages their life cycle, because there should be someone who should manage the life cycle of that container. Okay, so this is again requirement. Then the next is service discovery. Okay, how do they find each other, right? Because let's say as discussed in the networking part, there is a one container on the one machine and there is another container on another machine. Okay, now if they want to talk to each other, then to talk to each other we need to know some information, right? What is the IP of that, what is the host name of that? Okay, so all this information we should get it from the service discovery mechanism. Okay, so this service discovery mechanism should be there so that we should be able to find each other container. Okay, now then the next requirement is load balancing. Okay, that means let's say your application is running on 3-4 servers. Okay, and you are getting thousands of requests, so that's it's always important to load balance those requests and forward it to the server in a equal manner. Otherwise what will happen if requests are coming and if we that requests are going to this one server itself, in that case server will not be able to handle all these requests. So there should be someone who should rotate this request to all the servers which are available there. Okay, so that is nothing but a load balancing. So these are some requirement we need in a production as well as, so all this requirement to satisfy all this requirement we need a someone, so that is nothing but a container stuff. So all these requirements can be satisfied with a container orchestrated platform. Okay, so if you see there are a lot of container orchestrated platform available in the market. So if you see there is a one called Kubernetes, okay, which is the most used container orchestrated platform. Okay, so why it is most used? There are a lot of advantages of this Kubernetes. Kubernetes is open source. Okay, it has a huge community support. There are a lot of good features are available in the Kubernetes. Okay, so these are some advantages. Due to that, now in the market everybody is working on the Kubernetes. Now the next one is a Docker Swarm. Okay, so this is the default container orchestrator, comes with the Docker okay, this is the Docker community container orchestrator platform. It has lot of features. Okay, this Kubernetes is nothing but just built on top of this with the help of this Docker Swarm. But basically what is the difference between Kubernetes and Docker Swarm is that Docker Swarm can be used in the mid-level application or the small application, because if we have a very big application, in that case Docker Swarm will not work efficiently for very big application. Okay, so that is the reason Kubernetes is very popular. Okay, then there are some cloud provider like Amazon, Azure, Google Cloud. Okay, all these cloud provider also providing their Kubernetes service. Okay, so Amazon providing Elastic Kubernetes service, Azure provided Azure Kubernetes service, this Google providing Google Kubernetes engine. Okay, so all these are there, but those are paid because they are providing this cloud providers taking the cost out of it. Okay, so that's why the right now we have a few options, like there are others as well, like Mesosphere is there and some other as well. I don't remember the name of all, but nowadays in the market the two which are popular is Kubernetes and Docker Swarm. But again due to the some limitation of Docker Swarm, Kubernetes is more popular, and that's why Kubernetes is used in the community. Okay, so everywhere. Okay, so now let's go with the Kubernetes and see how we use the container orchestrator, how we can whatever the container till now we are launching, let's try to launch those container inside the Kubernetes cluster. Okay, now so what is Kubernetes? Kubernetes is a fully open source product. Okay, started by Google. Okay, it was started in 2014 and the first release of this Kubernetes is released in 2015. Okay, now what all the features this Kubernetes provides is automatic deployment, scaling, management of container application. Okay, then after that this Google has submitted this project to the CNCF, that is Cloud Native Computing Foundation, and then now this CNCF manages this Kubernetes product with Linux Foundation. Okay, this is 100% open source and this product is completely written in Golang. Okay. Now let's see the architecture of the Kubernetes. Okay, so if you see, as the way we have seen in the Docker, what we have seen is, what we do once we create the image, we push that image on the registry. Okay, that is nothing but a public registry. We call it as a Docker hub. Now we know that images are there, so what we do, let's say, there are basically two important components in the Kubernetes architecture. One is a master node, and we can have a multiple worker nodes. Okay, so to interact with this cluster, we have a three ways. Okay, we can use REST APIs, or we can use the UI, or you can use the command line interface. Okay, so out of these three, command line interface is more popular. Okay, and that's why this the name of this command line interface that we use to interact with the Kubernetes cluster is a kubectl. Okay, so if you see what is happening, we send the command request through any this interfaces. Okay, that request will go to the master, and there are a lot of components available in the master. So with the help of that, it will pass that request to the node, and any of the node will start that container. Okay, so before starting that container, it will go to the registry, pull that image, and then it will start the container. Okay, so this is the just a short flow. Okay, so now let's see what is the architecture of the master. Okay, now again, if you see, we have three ways to interact with the cluster. Now this is the master node, so the every request comes that goes first to the API server. Okay, so this API server is nothing but the location where every request goes. Okay, so this is the endpoint. Okay, from this endpoint only all other request, means all internal request goes. Okay, so first request, let's say let's go by with the example that I want to start one container, web container. Okay, so then first that web request comes to the this request comes to the API server. Okay, now API server forward that request to the scheduler. Okay, why this will be passed to the scheduler? Because now we want to start the container. Okay, so with the help of scheduler, we will decide which is the best node available in this cluster where I can start this pod. Okay, so here, instead of, okay, so let's talk about container only. What is pod, we'll see in the next video. So now we got the request to start the container. So now this API server will forward that request to the scheduler. Scheduler will choose the best node out of the all the nodes, and then once the best node is selected, okay, then that request will be passed to the node. Okay, now there are some other way tasks that scheduler do, but again it parallelly interact with the etcd. So what is etcd? Etcd is the NoSQL database. We call it as a key value database. So whatever happening in this cluster, okay, so all this data is stored in the etcd. So if someone wants that data, it will request to the etcd, and etcd will provide that data. Okay, so etcd is nothing but a NoSQL database. It's a database where all the information is stored. Now there is one more component called controller. So controller will do the task of controlling the nodes, controlling the container, controlling the pods, or health check of all these. Okay, so this is what controller doing. Controller has some components like replication controller, node controller. Okay, so all these controllers are there. Okay, all these controllers are just a sub component of main controller. Okay, now let's see the architecture of the node. Okay, so now what we have seen is, once scheduler get that choose the best node, it will forward that request to the node. Okay, worker node. Now on the worker node, we have one important component called kubelet. Okay, so kubelet is something like a captain of the ship. Okay, so this kubelet is a captain of whole this node. It will be in a continuous interaction with your API server, and it will keep updating the health of this node to the master. Okay, and also once we get the request on the kubelet, kubelet forward that request to the Docker. Okay, so now once that request come to the Docker, then the remaining flow happens the way we have seen in the standalone Docker. Okay, so now once we get the request to the Docker will start that container on this machine. Okay, so now here if you see here we call this containers as a pod, because pod is nothing but one logical entity where we can have a multiple containers or a single container. Okay, so now this Docker will start the pods in this particular node. Now if you see, there are some other components like supervision D, kube proxy, fluentd, DNS, add-ons, UI. Okay, so these are some plugins that we can use to get a better understanding or a better information about this cluster. Like this kube proxy is nothing but handling of IP tables. Okay, handling of IP tables is done through this kube proxy. Okay, so what is fluentd? Fluentd is a logging. Okay, it's a logger. Okay, so if you want to add some logging mechanism on the node, in that case we can install this fluentd component. It will keep a manage the logs of all the pods, okay, as well as node. Then you can install some plugins as well, DNS, UI plugin. Okay, so this will give more information about the node. Okay, and then this supervision D is to just monitor this node. Okay, now sorry, now this is the way typical scheduling of a pod happens. Okay, so let's say with the help of kubectl I am providing I want to start the one container. Okay, so I'm just writing one YAML file where all the details of my container is there. Then I'll pass this information to the kubectl. Kubectl will pass that request to the API server. Okay, so you can see in the first block, kubectl, here is a pod. Okay, and it is passing to the API server. Okay, and the parallelly all this information will be stored in the etcd. Now the next step is API server pod definition. Oh my god, a pod with a no machine assigned. Okay, so now in the second step, this API server will pass that request to the scheduler. Okay, now what this scheduler will do, scheduler will say that please assign this pod to the machine X. Okay, so with the help of some algorithm, it will choose the best node out of available nodes, and then sorry, and then it will choose the machine that particular node. Okay, and then it will again send back that request to the API server. Okay, and then parallelly all this information will be stored in the etcd. Now once we choose the node, the fourth step that will happen is it will send that request to that particular node. Okay, API server will send that request to that particular node, and that request will be sent to the kubelet. Okay, kubelet on machine X. So now what it is saying, oh my god, I'm supposed to be running that pod, I'll run it now. Okay, and then it will, this kubelet with the help of Docker, it will start the container for whatever the container we got the request. Okay, so this is how the typical flow of the this container launching happens inside this container management or container orchestrator. Okay, now let's see this in the practical. Okay, so what we'll do, we'll set up one Kubernetes cluster. Okay, and on that cluster we'll start the our pod. Okay, or our container. Okay, now before that, to set up the multi-node cluster, we need a multiple machines. Okay, but for learning or to understand the cluster, it is not feasible to have all the physical machine or the virtual machine to try out this. So for that purpose we have one utility called kind. Okay, so this kind is nothing but a Kubernetes inside Docker. So what will happen, this kind utility will start the Docker container as your nodes. Okay, and then we can install the cluster using all this Docker container. Okay, so what the definition is saying, Kind is a tool for running local Kubernetes cluster using Docker containers nodes. It was primarily designed for testing Kubernetes itself, but may be used for local development or CI. Okay, so we can use this for local development or continuous integration. Okay, so the long form of kind is Kubernetes inside Docker. Okay, so now first let's do one thing. Let's install this. Okay, let's install this Kubernetes kind. Okay, on your machine. Okay, let me install it. So I'm just installing it. So in the first command, what I'm just downloading this kind utility binary. Okay, and then in the next command, what I'm doing, I'm just changing the permission of that, giving executable permission, and then the last command, we are just moving that .kind utility to the local user bin so that it will be available. Okay, so now once kind is installed, with this help of with the help of this kind utility, we can set up the cluster. Okay, but to access that cluster, we need we know that to interact with that cluster, we have three ways. We can either interact with the UI or the REST APIs or the command line. Okay, so in this particular case, we are going to use the CLI. Okay, so with the help of command line interface, we are going to interact with the API server or the Kubernetes cluster. Now the CLI name that we use to interact with the cluster is a kubectl. Okay, so that we need to install. Okay, so now let's install it. So I have some commands to install it. So this command is just downloading this from the internet. Okay, so now it's just downloading, and then just change the execution, add the execution permission, and then move it to the user local bin so that this will be available in the path only. Okay, you can access this from anywhere. So now let's wait to have this installed. Okay, so it's almost done. It's now 85%. Okay, so it's done. Now let me move it to the user local bin. So now it will be accessible. Okay, so now if you run this, you can see that it's done. Okay, so now installation is done. Now let's create the cluster. Okay, so now to create the cluster, we have to provide this one configuration file. So let me just copy this configuration, and I'll tell you what is this configuration. First let me paste it. Okay, so if you see, what we are doing is we are giving the cluster name. Okay, sorry, kind is the cluster, and this is the API version, and then nodes. Okay, we are giving 3 nodes. We are setting up this 3 node cluster. So out of this 3 node, one is a control node, and then 2 are a worker node. Okay, so this is the configuration that we are giving in this config file. Okay, so now let's create the cluster. Okay, so now how we can create this cluster? Okay, so now to create a cluster, we have a command kind config kind create cluster -- config, and then that config name. Okay, so now if I run this, you can see that it will start downloading one image. Okay, and with the help of that image, it will start 3 containers. Okay, one will be the controller, and then 2 will be worker nodes. Okay, and then inside those container, it will deploy your cluster. Okay, so what it will do, it will internally install all the components. Like on the master node, we have seen that there are few components like etcd is there, API server there, controller is there, okay, and then scheduler is there. So all these 4 component will be installed on your master node, that is controller node, and then on the worker node it will install kubelet, kubeproxy, okay, then docker it will install. So all these components will be installed inside this node, okay, and also it will install the networking plugins as well, okay, like Calico, Flannel, okay. So any of one out of this plugin will be installed. So now let's wait to have this cluster installed on our system. So first time it will take some time because it has to download this kind est node version 1.18.2 image from the Docker Hub, okay. So this image is around 1.5 GB. So to download that it will take some time, okay. Otherwise for next time if you want to start the cluster or stop the cluster, it will hardly take some time, okay. So if you want to see how much how much image got downloaded, so let's wait for it. Docker images, you can do it. If I do Docker images, you can see that, okay, still now that image is not completely downloaded, so it will take some time. So let's wait for a couple of more minutes. By the time this image will be get installed, okay. Now by the time, let's see the Docker info. So in the Docker info it will show that where all these images are getting stored, okay. Docker info, okay. So what it is saying, what is the location of the images that it is storing. Root dir, this is the storage location, and this is the lib docker, okay. So let's see, is there anything we can find it here. Okay, let me use the sudo. So there are a lot of things are available here, so it will take some time. It's still downloading it, so just wait for this. You can see that here what all this, okay, we have an image here. AFS destination image DB, runtime SOM TMP trust volumes, okay, but this is not the exact location where all these images are getting stored. Let me just have a look. Docker lib, so inside lib we have a init script, or let me check inside Docker. Containers, okay, so inside container it is showing just ID. So image is yet to download, so it's almost done now. It's showing some okay guys, so looks like the cluster is ready now, okay. So how to access this cluster, okay. So before accessing, let's see what all things happened here. So first what has happened here is downloading of the image, okay. So as discussed, this kind will create a cluster using Docker containers, okay, and then it is preparing nodes. So here you can see that 3 nodes are getting created. Then we are writing the configuration for all this cluster. Then starting control plane, installing CNI, okay. CNI is this container network interface, okay. Then installing storage classes required for this. Then joining worker nodes, okay. So we need to join the worker nodes as well, okay. And then setting kubectl context to kind, and now it's ready. Okay, so now if you just access this command cluster info, here you can see that it will show the cluster info of this C. So what it is saying, Kubernetes master is running on this and the DNS is running on this. Okay, so now let's start accessing this cluster. Okay, so how to see all the details? So here you can see that kubectl get first nodes. Okay, so now here you can see that there are 3 nodes. Okay, it's a controller node and there are 2 worker nodes. And if you want to see more information, you can see that -o wide. So now you can see that what all things we can see. Name of the cluster node, it's in ready state, role is a master, it's running from 22 minutes, version of that cluster, the IP of that node. Okay, then external IP, not image. Okay, it's a Ubuntu 19.10 image, kernel version, container D, container runtime. Okay, so all this information is there. Okay, so now let's see the pods. Okay, so if you see, there are no resources found in default pod. Okay, so the namespace, if you don't provide any namespace, in that case the namespace is a default one. Now, but if you see, okay, let's first see the namespaces. Okay, for to get the namespaces, you can type complete word namespaces, or you can use the short name ns. Okay, so now you can see there are total 4, in fact 5 namespaces are there. So the default is the default namespace that we are using now. Then there is a kube node lease. Okay, in this node, okay, this node is nothing but the which is created for this cluster. Okay, so if you do something like this, let me first set the alias so that I don't need to use this kubectl command every time. Okay, now I can do get nodes -n, namespace that I want to use is kube node leads. Okay, so you can see that all these nodes are inside this particular namespace. Okay, if you see the nodes inside this kube public. Okay, or let me show you the pods. Okay, get pods -n. Here you can see that there is no pod, but there are nodes. Okay, so all these nodes are inside this. Now let's see the nodes. kubectl get po kube public. Okay, so this po is to get the pods. Okay, kube public not found. Okay, so this namespace is not there. Okay, sorry, it's not po -n. So you can see that there is nothing inside this. But the more important, let me show you the first this namespace get po -n. Now inside that, this is the one running container is there. Okay, running pod is there, which is used for storage. Okay, so for now we can ignore it, but the important namespace that we have is the kube system. Okay, that is what I want to show you here. get po -n kube system. Okay, now this is important. So here you can see that what all pods that created. Okay, so we know that. Okay, let me add the -o wide here. It will give more information. Now let's go from the bottom. Okay, so you can see that the scheduler, okay, kube scheduler, which is hosted on the control plane. We know that on the controller node, that is on the master node, schedule is there. Then this proxy, okay, kube proxy is available on all 3 nodes, that is worker 2, worker 1 and control plane. Okay, and then there is a control manager. Controller manager is available on the control plane. Okay, that's control master node. Then API server is also available on the master node. Then there is a kindnet. Okay, kindnet kindnet is a CNI plugin. Okay, kindnet is a CLI plugin which is available on all these three nodes, and then etcd should be in control plane. Then this DNS service, okay, this DNS service required on the it should be on all three nodes. Why it is showing only on two nodes? Okay, fine. So it's available on control node 2 and the master node. Okay, so now these are the some inbuilt component that we required so that this kind has started. Okay, now the next thing that we need to do is now we know that, okay, we know that let me show you first docker ps. Okay, you can see that only these three containers are running. Okay, now what I want to do is I want to start this container. Okay, I want to start this container inside the Kubernetes. Okay, till now what we have done, we are starting this container as a standalone, but in this case what I want is I want to start this container inside the Kubernetes. Okay, so how you can do that? So for that we have a very simple command. So kubectl run, we are giving this name for the pod, that is my web app, images Rajendra IT web, and restart never. Okay, so now if I do k get po, that is pods, you can see that one pod got created. It's showing status container creating my web app. Okay, still it is container creating, means it's a pulling the image. If you want to see more information, what we can do, k describe po my web app. Okay, my web app. Now if you run this, you can see that what is the events happened here. Successfully assigned default web app to kind worker, pulling image. Okay, so now it's pulling image. Again let me describe it. Okay, it's again pulling image, it's still pulling. So once pulling is done, this is we are doing first time, that's why it is taking some time to pull that image. And once pulling is done, it will deploy this. Okay, it will deploy this on the worker 2. Okay, still the status is container creating. So let's wait to finish this downloading image task. Sorry. Okay, still pulling. It's taking enough time. So maybe it will take 2-3 more minutes to download the image, because it's a huge one and it will take some time. So once we see this is in a running state, we should be able to see more information. Okay, the status is still container creating. Let me describe. Okay, still it is pulling the image. Okay, still taking time to pull it. It's almost now more than 2.5 minutes, but yeah, so this is the first time, so it will take time, which is expected. Okay. Okay, this particular image, in fact this downloading will be depending on your network speed. Okay, so maybe right now my network is not giving the good speed, so that's the reason it is taking. Okay, so pulling of image is successfully done. Okay, now you must be seeing one more status there, creating container web app, started container. Okay, so now if you see the get pods, you can see that your web app is running. Okay, but okay, if you see the command that we used, okay, so we just started the pod, we didn't expose that. Okay, if you see, if I do get svc, okay, svc is for to get the service. there is only a Kubernetes service, there is no service created for this. Okay, so what I can do, k expose po my web app hyphen p. Okay, let me just get the command. So what we have to do, k expose po my web service. Okay, so my web app, it's we have to give the pod name. Okay, then hyphen type is a node port, then hyphen port. Okay, this is running on 8080, and hyphen name is web service. Okay, so before running this, okay, if I try to access this application, okay, it will not be accessible. Curl localhost 8080. Okay, so why it will not be accessible? There is some reason, because we didn't bind host port as well as the container port. Okay, so that's the reason it is not accessible on the host. Okay, but if you see, if I do kget po hyphen o wide, okay, it will show where this particular pod got started. Okay, so this particular pod is started on the kind worker. Okay, so now this is the pod IP. If I do with the pod IP curl this pod and 8080. Okay, okay, it's not responding. I just want to see this application on which port it is running. Okay, so it's not responding. That means there is nothing running on 8080 port. But let's verify it whether it's running on that or not. So for that, what we can do is we can log in inside the container. Okay, fine, it is not responding. What I can do is kubectl exec hyphen it. Okay, my web app. Okay, do ps. ps hyphen ef. Okay, it's not doing it. It's a better web app. Okay, now we are inside this container. kubectl exec pod command is deprecated and will be removed in future version. Use kubectl exec view command instead. Okay, fine, let me do ps hyphen ef. What we can see here is there's a HTTP server is running, but what it is doing, cat http underscore server dot py, not server, it's a cached http underscore serve dot py. Okay, it's running on 8080. Okay, there is no reason. So let's see the log first. Docker, not docker, this time we use kubectl logs. Okay, po my web app. Okay, you can see that this is running, so it should have been accessible, but somehow it is not accessible. But we'll see that why it is not accessible. Okay, so what we have to do first, let me do the kget nodes. sorry, hyphen o wide what I need to do is k get po hyphen o wide on which node it is launched, that is kind worker. Okay, so this one is the 172.19.0. so if I do curl 8080, it's again not accessible, but from here let me do login here. So I'll do docker exec hyphen it, and then its name is kind worker. Okay, as such. So I'm inside the container now. Sorry, let me do ls here. So what I need to do first here is I need to check if there is a curl command. Yeah, curl is there. Curl localhost colon 8080, it's not accessible, and let me do this as well. Yeah, from here it is accessible because this particular pod is deployed on this node. Okay. So now it's accessible, but outside it is not accessible. Okay, so to access this outside, what we need to do is what we have to do is, just a minute, to access, to make this pod accessible outside that node as well as outside this cluster, what we have to do, we have to create a service. Okay, so this service will help us to expose. Okay, so we are creating services, nothing but we are just binding the host port and that container port, so that if you want to access that particular application or the container, the first request will go to the service, and then service will pass on that request to the particular container. Okay, so how we can create a service? Okay, so for that it's a simple one, k expose. Okay, then expose po my web app. How I want to expose is hyphen hyphen type. How I want to expose, it's a node port. Okay, and then the port that I want is 8080, and then service name is web service. Okay, web service. Now that's it. If I run this, you can see that service got created. If I do get svc, you can see that this is the new service which is got created. Okay, so now if I try to access this using this server IP, service IP, and if I do 8080, okay, it's not accessible. But if I do service 31367, here as well it is not accessible. But now if I do localhost, it should be accessible, because 31367. Okay, so it should be accessible from that node itself. Okay, but from that node itself, okay, 31367. so let me log into that node first. Let me go back where, okay, yeah, this is the node. Now I logged in, curl localhost colon 31367. Okay, so now from the node as well I'm able to access it. Okay, but it's not feasible that we will store so we will provide this IP to the means it's not feasible. Let's say on the first time my pod got launched on the node 1, second time it got launched on the node 2, then again node 3. So every time if IP is going to change, then in that case it is not feasible to accessible node. Okay, so for that we have one way. We can give a external IP while creating a service. Okay, so now if I see get nodes hyphen -ovide, you can see that on what range this IP got assigned is 234. So if I give IP this copy is, let's say 0.5. okay, so this 0.5 IP will be accessible from here, and then we'll be able to access that service or the node directly. So what I'll do, k if you see k expose, or if I do k edit svc web service. Okay, so this is our service, and now I want to expose this service. Okay, so how I can do this? So there is a cluster IP, and we have a one more is external IP. Okay, so that I'll give as a 5. Okay, so now this is the IP. What it is saying, please edit the object below, lines beginning with hash will be ignored. Okay, it's showing that it's invalid. Okay, so for that what I can do, k explain po dot svc dot spec. Okay, now let's check, it will give all the information regarding this. Okay, it's a external IPs. Okay, what we have done, we have given is a external, and it's a list of strings. Okay, list of strings. So this way we need to edit it. Okay, so what I'll do here, cluster IP external IPs. Okay, and then let me just add this IP 172.19.0.5. okay, let's check if it is working. Okay, it's not again working, so still we are missing something. It's a small change in fact, but we need to understand how we can do this. So it's a list, so what I can do is go to the new line. Okay, and then this add as a list. Okay, so now hopefully it will work. Yeah, it's got edited services, web service edited. Okay, now if I do get svc and then the external IP that we use, this one. Now let's try to access this curl, and then the IP that we used is 31367. okay, no route to host. Let me check if I can ping this IP 172.19.0.5. it's not accessible from here. 4, yeah, 4 is there. 2.19.0. What's the problem to access this? It should be, let me check the route -n 19.0.0. it's passed to the bridge. Okay, let me just quickly have a look and then we'll continue. 5 मिनिटं रे